We are going to study formation of ionic compounds. Let's take example of NaCl. Now, Na has electronic configuration 281. It gives out one electron to form Na plus ion. Now its electronic configuration will be 28 and one electron it has donated. Now consider case of chlorine. So chlorine has electronic configuration 287. It accepts one electron. So it forms Cl minus with electronic configuration 288. Now Na plus and Cl minus combine to form NaCl. So we can write Na and we can show the transfer of electron to Cl plus Cl. Here this electron is being transferred to chlorine, and chlorine has already 7 electrons in its outermost shell. This gives Na plus, and since Cl has accepted one electron, so it will be Cl minus. We can show the electron that has come from Na and then rest electrons. So this is how we have got NaCl. Now let's study the formation of MgCl2. So Mg has electronic configuration 282. It can donate 2 electrons. So it will form Mg double plus. Its electronic configuration will be 28 and 2 electrons. Now consider the case of chlorine. Its electronic configuration is 287. It accepts one electron to give chlorine negative ion. Its electronic configuration becomes 288. Now let's see the formation of MgCl2. So we write Mg here. Mg can donate 2 electrons, so one electron here, another electron here, and we consider 2 chlorine atoms, Cl, Cl. So outermost shell electrons of chlorine are 7, so they are shown here. This electron will be transferred, and this electron will be transferred to this chlorine atom. So it will be written like this: Mg 2 plus, since it has donated 2 electrons, and chlorine, we will write one chlorine atom, and the electron that has come from Mg, that, and then other electrons. This is negative sign because it has accepted electrons 2, which means Mg cleared 2. Now let's take example of Na2O. So Na has electronic configuration 281. It can donate one electron to form Na plus 28 plus electron. and oxygen has 6 electrons in its outermost orbital. So its electronic configuration is 2, 6. It can acquire 2 electrons to form O double minus, and the electronic configuration will be 2, 8. Now let's see the formation. So we have to take 2 Na, one electron of this Na, the other electron of this Na will be transferred to oxygen, which has 6 electrons in its outermost shell. We can show this transfer like this. So this becomes an A single plus, rootwise, and oxygen double minus. Since it has acquired 2 electrons, so those 2 electrons, then rest electrons of oxygen 6. So this is how we have got Na2. Now take example of MgO. Mg has electronic configuration 282. It can donate 2 electrons to form Mg double plus. Electronic configuration will be 2, 8, and 2 electrons, and oxygen has 6 electrons in its outermost shell. So we can write its electronic configuration as 2, 6. It requires 2 electrons to give O minus 2, and electronic configuration becomes 2, 8. Now let's see the formation. Mg, it is transferring 2 electrons, and oxygen, it is taking these 2 electrons. So transfer will be like this, and then final situation will be Mg double plus, and oxygen, it has acquired 2 electrons. Here double minus. So this is how we have got MgO. Thank you.